today. My name is Seth Carpenter, and this is my partner on this project, Austin Cheng. And our project deals with integrated smart home technology.
Now, you're all familiar with the traditional doorbell. It's simple, but fairly effective. There are, however, certain circumstances where it just isn't effective enough. One such circumstance, which ended up being the inspiration for our project, is the inability for those suffering from partial to severe hearing loss to actually hear a doorbell. And our solution comes in the integration of embedded systems in smart home lighting technologies. And what do I mean by smart home lighting technology? Meet the Philips Hue.
Here, let me get that microphone. So, the Philips Hue is a customizable LED lighting system that integrates with your home network. It supports many bulbs. We found that it supports up to 50 bulbs. The lights are controlled by a central bridge, which you can see on the slide there. It's that little white box is the bridge that controls all the bulbs, and that bridge accepts JSON requests and passes those along to control the bulbs. In our project, we have an Arduino sending these JSON requests to that bridge. And this is an Arduino Uno, the type that we use for our project. It's a small 16 megahertz circuit board. It can be powered via the wall or USB. We have it plugged into a USB connected wall outlet thing. And it uses a C++ type language to code. And we use two of these on our project, one for the receiving end, one for the sending end. And for one of our Arduinos, we put an Ethernet shield on it to give it network connectivity. We're also using XBEEs in our project, which are tiny little radio transmitters that can be powered off of 3.3 volts or 5, and they're very efficient, and they sleep when they're not in use and have other power-saving features. And this is an overall diagram of the infrastructure of our project.
So on the left side of the diagram, you can see the sensing component comprised of the passive infrared sensor, an Arduino, and an XBEE. And on the right side, you also have another Arduino. That one will have the Ethernet shield, and it is also connected to an XBEE. Now the Ethernet shield allows it to be connected to your home network, and the bridge for the Hue lights is also connected to that same network. And you can see that the bridge sends commands wirelessly to the lights, and the Arduinos also communicate wirelessly. Now moving on. Within the sensing component, you have this passive infrared sensor, and it is in a passive state when there isn't anything to trip the infrared beams that it sends out in order to sense any sort of movement. When it does sense movement, it sends a voltage to the Arduino, which in turn is coded to send a character through the XBEE to the other end whenever it's triggered. And Seth will explain the receiving end.
So on the other end, once that character has been sent out from the sending end, I receive that character with my XBEE, and the XBEE tells the Arduino that it's time to take action. And the Arduino is running an HTTP client, which sends a put request full of JSON data over to the Hue bridge. And the bridge understands JSON and sends that command to the lights to change the color or send an alert. So when somebody walks up to the door, you're going to see an alert at your desk. And we also program the Arduino to remember the current state of the light so that when the alert goes off, it reverts back to the state that you had it configured in the first place. So if you have a custom color or something, you want to keep that and not lose it whenever an alert goes off. And we have a video demo here to show you.
we have the first component there, which is powered by a USB wall charger. And the second component is also powered by a USB wall charger. So we have it connected to a network router, and that's going to be connecting to the receiving Arduino and the bridge. And in this demo we have two lights which represent any number of lights within your house. And as someone passes the infrared sensor, the notifications are sent to the lights and they change colors and then change back to their original colors. Now this also works when the lights are off as long as they are powered. And they will send the notification and then return to an off state. Now, there's a lot of potential in a system such as this. It can be adapted to use several different components thanks to the flexibility of the Arduino and the components that it utilizes. It's very easy to prototype and develop these components, and just today we decided to prove that by adding another feature to this system. Now, at the moment, we've only been able to work with two different lights because we've only had two lamps. So this differs from the example we showed in the demo in that...
So we're going to do a live demo now.
Right.
We only have one microphone.
So when the infrared sensor is tripped, again, the indoor lights will send a notification to whoever's inside. And when the person receives that notification, they can alert the person outside that they've acknowledged that notification. Is it?
Yeah.
Okay.
Sorry, was I in the way of the camera? Good. All right.
And so systems such as this, with all of their customizability and flexibility, are really the way to lead into full home automation. And it doesn't even have to be limited to just residential applications. Applications like this can be extended to the private sector, the military sector, or health sector. For example, you could use a system such as this in a hospital to notify nurses and doctors of emergency response codes. Or you can use this to alert associates of unauthorized intrusion in anywhere from data centers to military bases.
So in researching the competition, we found a few alternatives that range from $9.99 for like a really chintzy model to over $100 for really commercial grade, tough, like stuff that would be approved for commercial enterprises. What we have over them is that they do not integrate with any existing systems. They are a separate deal, and there's really there's just a big flashing light, and they're not customizable in the color of the lights and that type of thing. The advantage they have, they could be more affordable, but if we prototype this enough and get it down to where we don't need a full Arduino to power it, we could get the cost of our system down far enough. But if you already have a Philips Hue system in your house as well, this is a lot cheaper option, or a lot more integrated and works with what you already have.
All right, so to conclude, as we said earlier in the presentation, this was built off an idea to provide accessibility options for the differently abled. But it's just a nice kind of vision into the potential for integrated systems within the home. And like it says in the slide, this is just the beginning. Hopefully we'll soon see a house that might even be quite like the old Disney movie Smart House there that I put a picture of, which I admit I watched quite often. But yeah, thanks